doesn't really affect much. Okay, so we got a long problem, but there shouldn't be too much calculation, right? It's a lot of conceptual stuff here. So how would you go about doing part A? Split the integrals. Yeah, we just split the integrals. In fact, I'm actually going to draw a graph here. So draw a graph to help visualize. I think that's usually how I do these problems. That's how I did the exam problems myself. So even though we don't know what f and g look like, when we draw f and g, just kind of draw them randomly, right? Just so like that. Copy. Because I need a graph of f and I need a graph of g. Okay, so here's 3, here's 8, here's 3, here's 8. So the first integral says the integral from 3 to 8 of f is 9. So let's make this, so here's f, whatever. So the entire region has area 9. Right. So that's, I'll write the numbers in just a sec. We want to see exactly where when I put them. And the other integral says from 5 to 8 is just 4. So that'll be a second integral. Let's make that say red. Or actually, it's probably easier if I do it like this. Okay. So the red region has area 4, and the entire green region has area 9. Okay. The whole thing. So you can actually already see, if I asked you, what is the integral of f from 3 to 5, what would you say? You can see it's 5, exactly, right? I mean, the right part has area 4, the whole thing has area 9, so the difference just from 3 to 5 is area 5. Okay, and now for G, let's do kind of the same thing, right? Let's make it look different. Here's G. We're told the whole entire area from 3 to 8, that area is 5. But the integral just from 3 to 5 is 2. So if I asked you what is the integral from 5 to 8 of G, what would you say that is? That's just 3, right? What if I asked you what is the integral from, say, 2 to 8 for f of x, from 2 to 8? What would you say? It looks like this is right, not enough info. Make sure you said it does not exist. It does exist. The integral from 2 to 8 does exist, right? Because the area from 2 to 8 does exist. It's just that we don't have enough information. We don't know what f looks like in this region, so I can't say exactly. Right? You can't say that, say, from 2 to, I said 2 to 8, so 2 actually goes over here. I don't have enough information for f from 2 to 8. If I asked, say, 4 to 8, that'd be kind of in between. It's not necessarily an even split, right? So unless these limits have something to do with 3, 5, or 8, I really can't do anything. All right, now let's actually answer the questions. The first question asked us, what is the integral from 3 to 5? Yeah, 3 to 5 of 9 times f. Now, how do you do this? The 9 is a constant coefficient. So the 9 comes outside of the integral, and I just get the integral from 3 to 5 for f. Now, you just told me that this integral is what? It's the leftover piece, right? The integral from 3 to 5. So the whole thing was 9, but this little piece here was 4, so the leftover was 5. In fact, you can say that that piece is 5. Right? And we can say that this piece, since the whole thing was 5 and the red piece was 2, the blue piece is area 3. Right, so we get 9 times 5, which gives me 45. Okay, now we should be able to do the rest fairly simply. 3/8 f of x minus g of x. How would you do this? 9 minus 5, right. It's the integral of f minus the integral of g. Okay, keep going. C, D, E, F. So the next one, part C, was the integral from 3 to 5 of f of x minus g of x. Right? So again, we subtract, right? This is the integral from 3 to 5 minus the integral from 3 to 5 of g, right? And because we've done all that work earlier by drawing the graph, this is actually very easy now just to read off, right? We get what? Blue on the left minus red on the right. So we get 3 for that answer. Oh, I keep looking at the answers for the Pearson problem, but when they reloaded, they also changed all these numbers 5, 9, and 4. Okay, it doesn't matter. I'm not going to redo it. Okay, so part D, 5 to 8 of g of x minus f of x. Okay, again, same thing, right? You split it up. So this is integral of g minus the integral of f. And now we read off from the chart, or the graphs rather. So the integral of g from 5 to 8 is the blue region, that's 3. And the integral of f from 5 to 8 is the red region, that's 4. So I get here -1. And so on and so forth, right? Now we get integral from 5 to 8 of 5 times g of x. The 5 comes along as a coefficient. And the integral from 5 to 8 is this blue region. So I get 5 times 3, I get 15 here. Okay, and then finally I have the integral from 3 to 5. No, I'm sorry, 5 to 3. Whoops. One messaging me on Discord. So the 3 comes outside. So this is the only kind of tricky one. So the coefficient of 3 comes outside as a coefficient. Now, what about when I have something like this? I want the integral from 5 to 3. So in other words, I'm going from 5 to 3. I'm actually going backwards from 5 to 3. What do you know about that? What do you know about integrating backwards? Would it be negative instead? Yes. Actually, when you integrate backwards, it actually causes so you can actually flip it back, go from 3 to 5, but I get a negative, right? So integrating backwards actually does give you a negative. The integral from 3 to 5 was that blue region, so that is -15. Yeah, less the part F, yeah, the area is negative. That's because we're integrating backwards. Notice we're going from 5 to 3. So if you're going backwards, right, I'm starting at 5 and I'm going backwards to 3. The convention is that that actually gives you the negative of going forward. So if I were to go from 3 to 5, I take that instead, but make it negative because I was going backwards. Does that problem make sense to everyone? I definitely do think problems like this, where you're given some information about the integrals of a function and then you have to kind of combine them. I find it always much easier to draw something like this. Like before you even start on the problem, take the information that they have given you and try to draw a graph that is consistent with that, right? Because then it becomes very easy for kind of picking out the regions you want, right? I want this red region, I want this blue region, right? It's very easy to do that. Right, you're relying on your intuition of integrals, right? That I can split an area into two separate pieces and add them together, right? You're relying on that geometric intuition. A general rule: if you do not have information, I mean, if you don't have enough information, that's it. I mean, for instance, if I asked you, if any of these limits of integration, for instance, if any of the limits of integration were not 3, 5, or 8, I would have no information, right? Because, for instance, if I asked you the integral, say, from 6 to 7, right? I don't know what this function looks like in that interval, right? Makes no like I have no information. So that's kind of one rule, right? Or if I somehow didn't give you enough information to figure out these two pieces, right? But I did. So, all right, so we have about 10 minutes left. So we're kind of in that area now where I think we just have like maybe time for one more short problem, and then we can always pick this up again tomorrow. We have 16 5.5, so if that's a short problem, we can do it. Is this textbook or is this homework? What is this?